Hello and welcome to Physics 2B Section 7, the asynchronous section of Physics 2B this spring 2021 semester. This is how lectures are going to be handled throughout the semester. I am pre-recording lectures that are going to last for at minimum 45 minutes. Many times they'll go the full hour and 15 minutes. And during that time, I'm going to be going over the same thing that I'm going over in my other two sections. Today, I'm going to go over what's happening on Canvas itself here. Then we're going to take a look at the syllabus. And then we're going to take a look at the PDF book. Okay. There's a few other things that are here because students have added them or suggested them. That's this line right here. Okay. There's a student-created Group Me page. Not a forum I'm familiar with, but it's a place where you can interact with other students in a text message type thread, I believe. And Physics2B Discord page. I do use Discord for other things, and it's been good for both text and video chatting. So good interaction place where you can have inter-student communication. I do have my own spot on Canvas for you to have assignments that involve communication with other students, specifically the discussions. Okay, but we'll get to that after while I'm going through the syllabus. Okay. By the time that you have opened this video, where it says lecture video should be a link. The video that you're watching right now. So that's where the lectures are, right there, in the same line as the day of the week. Not to be confused with old lecture videos. These old lecture videos are primarily from last summer, summer 2020, when I first taught a class asynchronously like this. When you click on the syllabus, it brings you to this. You're in the right place if you're here for Physics 2B Section 7. Right. Asynchronous. Asynchronous doesn't mean you have the entire semester to do things, though. I do have assignments for you to do 2 days a week. So there's a pacing to the class still. This will help you not fall behind. I've seen other asynchronous courses back in the day that were very open-ended, so that people could finish assignments whenever they wanted. And some students just did everything in spurts and then ran out of steam. Other students just got distracted and then had to do everything at the very end of the semester. Instead, this version of an online asynchronous course, I specifically have everything paced so that if you stick with the course, if you're watching the videos twice a week, and if you're doing the small assignments twice a week, you don't fall behind. And that way you have a schedule, that way you have a routine that you can still stick with, that you can mesh into your schedule as need be. If you need to contact me, if you actually need to converse with me, we've got two big ways for you can contact me. One, email. If you use the Canvas messaging service, that also goes to my email. So really it's the same thing to me. Anytime you have a question, please feel free to send out a message. If you want to set up some sort of Zoom meeting at any time, let me know. I do try to get to emails within an hour or two. If it's the middle of the night, you're going to have to wait. But if I do not get to respond to your email within 24 hours, do reach out again, see if there's just something off. Over the weekend, I am slower at responding to emails, but during the 5-day period of the week, I should be right on it. Actual office hours, where I plan on just being available for you guys no matter what. Friday, noon to 3 p.m. I do not have a set Zoom link for that. If you want to meet me during that time, just send me an email to the same email address above, either the night before or even during that office hour time, and I will email you the link and see you during that time. Okay, so that's how to contact me. What are we doing with all this interaction time? Well, we're studying electricity, magnetism, optics, and atomic physics. There are 2 books for the class. There's one required purchasable text, College Physics, A Strategic Approach to 4th Edition by Knight. It is not necessary for it to be the 4th edition, though. In fact, the one that I have on my desk right now is actually the 2nd edition. So 2nd edition's fine, 3rd edition's fine, 4th edition's fine. I don't think they have a 5th edition yet. I have had a student use the 1st edition, and it worked fine. It was just kind of meh. It was all black and white and no pictures in it. So I think that the 2nd, 3rd, 4th edition are the good ones to go with. And if you look for the 2nd edition, you can get it way cheaper than you can the 3rd or 4th. I said that there's a 2nd book as well. And the 2nd book is just going to be used during the first half of the semester, first third of the semester, really. And that is the PDF book. Okay, the PDF book is written by me. It's available right there. It's free. It's what we're going to be using most of the first third of the semester. The reason why we're only using it for the first third of the semester is that I'm still writing it. I'm going to try to include a little bit more material in it, to at least get circuits in it, but I do not see myself getting a magnetism chapter in it this semester. Okay, so that's the 2nd book. It's free, it's right there, download it, whatever. In fact, the assignment for the weekend, the discussion, involves a page in the PDF book that I will be going over after I've gone over the syllabus with you guys, for you guys. Let's switch up the color. Learning objectives. This right here, mostly I have this in here for getting a good syllabus for if you needed to transfer this course to another institution. That's what they look at right there. They want to know everything that is actually covered in a course when they look for equivalency. If you are interested in what is being covered the entire semester, go there. But really, it's best for you to just think of it 1 unit at a time. And starting next week, we're going to be talking about electric force. Okay. Today, for the second half of lecture, we're going to be doing more of a 2A review. Make sure everyone has the prerequisites in a comfortable place, not just passed in a previous semester. The other stuff: electric fields, DC electric circuits, magnetic fields, magnetic induction, AC electric circuits, reflection, refraction, lenses, optical instruments, interference and diffraction of light waves, and lastly, atomic physics. We got the whole semester to talk about that stuff. Reading. The reading is highly suggested. You can see the pacing of what you should be reading in the Canvas page. There's no reading set for this week, but there is reading suggested for next week, week 1. Chapter 20, that's the numbering that's in the Night book, and it covers fundamental charges and Coulomb's law. So as you scroll through the rest of this, I didn't take a picture of the entire column. You'll see the pacing of how much reading is expected from week to week. And it's approximately a chapter per week. This is what it averages out to. Homework. Homework falls under all of these sections right here. Okay? There's homework as in what I think you should be studying. Okay? And everything that you study doesn't mean that you need to turn everything that you study in. The only thing that I want you to turn in are the warm-ups and making entries on the discussion message boards. You're going to see an example of the warm-up next week on Tuesday, because that's when the first warm-up is available. It's going to be based off of the stuff that's in today's lecture. It'll be 1, maybe 2 questions. And if you've studied the material that I'm going over today, then you should have no problem with the warm-up at that time. The message boards are meant to be a discussion group. That's why it's discussions, where I have multiple prompts available to you, and in those multiple prompts, I'm expecting you to engage in many of the questions. For example, the discussion that's due Monday night for the section 7 is based off of what's going on this page, which is also where the warm-up next week is going to come from. Okay, so I'll be I'm not looking for you to answer every single one of these yourself. I suggest that you study all of them and make sure that you can do them yourself, but that's not what I'm asking you to turn in the discussion. I'm looking for you to ask a question, such as, how would you approach what a specific part of this question? Or maybe you're answering someone else's question, saying, I see the distinction between speed and velocity. Remember that thing in 2A when we were transitioning from energy to momentum? During the energy unit, we kept on using speed to describe the motion, whereas in momentum we used velocity. And that was because we were transitioning from talking about scalars, energy, and speed in the first half of the semester, whereas in the second half it was vectors. So vectors would be velocity and momentum and forces. So even though speed and velocity both have units of meters per second to describe the motion, they're different because speed is a scalar and velocity is a vector. Now, I just gave a very extensive answer. I'd consider that to be a long answer. But that kind of back and forth of someone having something where they're stuck and someone else coming in and helping, that's what I really want this discussion board to be. Very similar to if you took 2A at San Jose State, how in your discussion groups during lab time, you'd be bouncing ideas off of each other at that time. Similar idea here. Okay. This should be a source of interaction in the class. So. Other things that you're actually going to be graded on? Tests. There's always tests. Okay. The Unit 1 test is going to be after electricity and DC circuits. Unit 2 test is going to be after magnetism and AC circuits. and the final is at the end of the semester and will be cumulative. It's going to primarily cover the last third of the course, but it will be cumulative. I'd say over half of the exam will be on the last third of the class, and I'd say somewhere between a third of the exam and 2/5 of the exam will be based off of the first 2/3 of the course. These 3 tests account for 30% of your overall grade. That means that each exam is worth 20%. Your warm-ups and discussion, they're worth 20%. And your lab grade. So whomever your lab instructor is, I'll be getting a report from them at the end of the semester, and I'll be averaging their lab result into your overall grade. All right. I'm willing to have some wiggle room, but not a lot of wiggle room on these. I'm really wanting the exams to be in the morning on those days. If that is going to be an issue, please let me know beforehand. Note that I'm not saying that you get the full 7 to noon. I'm saying that's when it's available. More specifically, each exam is written to take 1 hour and 15 minutes to complete. Okay. If you have any special test taking needs that you have documented with the AEC, which I think I have a statement about down here. If you have something documented with the AEC, let me know. The university may have already let me know. I've gotten a few emails already, and I can adjust test taking accommodations accordingly. Okay. So that's what you graded on this semester. These types of homework, 3 exams, and your labs. If you are good at keeping up with the warm-ups and discussions, then you should be ready for the tests with just a little bit of practice going into them. Course grading scale, you may notice something slightly different than you've seen before. I do a 5% per plus or minus. So A plus goes down to 95, A goes down to 90, A minus goes down to 85. Same pattern for B's and C's, but then I break that pattern for D. And the reason I break that pattern for a D is I found D to be a very useless grade in college. I think it was 2 D's in my lower division courses when I was in your guys' place, and both times I was like, well, I gotta retake the course because it's not gonna really count for anything. It doesn't fulfill prerequisites, so I'm kind of keeping that as kind of a tiny buffer. I don't give D pluses, I don't give D minuses, just in that 5% range, D. And then anything below 50%, F. I usually end up only giving Fs to people that end up giving up. If you are falling behind, if you're looking at things and realizing that you're not doing as well as you want to be doing, please contact me and let me know what's going on. I can possibly provide extra office hour times. I can offer suggestions, or maybe you end up just needing a study group. And so use the different types of discussion we have available if you just need someone else in the class to talk to, whether it be the discussion boards, the Discord page, the GroupMe page, or during your lab time. You should have plenty of times to interact with other students to build up a good study group so that you don't have to do this alone. Okay. Don't cheat. That's this paragraph right here. Basically boils down to that. I have had to deal with cheating in an online class already. It basically made me really frustrated with everyone, not just the person that cheated, for about a week. So please don't. It it I've cheated in the past. That's largely connected with the D's that I mentioned previously, and it just meant that I had to go back later and actually learn it later. Um, Cheating gives the illusion that you know it, but it doesn't actually help you know it. And that's what this course is all about, learning stuff so that you know it. Not being able to find answers, but being able to figure out things for yourself. Okay, so just be honest about what you're turning in. That's the big thing. All right. That's our syllabus. Usually at this time, I'd take a quick roll call of the class. Not going to do that for the asynchronous class. And I would see if you guys have any questions. If you do have questions, please send them through to my email. If it seems like something that the entire class should know, then I will make an announcement to the entire class so everyone knows. Okay. Next, the rest of our time today is focusing on Are You Ready? Are You Ready is the first big section from the PDF book. So where do you find this? If you click on PDF book, and you'll see a table of contents. Click on Are You Ready in that table of contents, and it will jump ahead to the Are You Ready questions, which is this page down here. Okay. This is all about what did you get out of Physics 2A. Now, there's some issues with what people got out of Physics 2A. For one, we got people coming from different institutions. I expect the majority of you took 2A at SJSU in the past 2 years. Okay? If that's the case, I know exactly the curriculum that you had covered. I actually wrote a couple of the activities in the lab manual that they use. So I know that lab manual backwards and forwards. So I know what you did cover, and I do know that there are things in here that weren't covered there. For example, number 8. Number 8 is a torque question. And for some reason, torque hasn't been covered in Physics 2A at SJSU for about 4 years now. Why do I have it as an Are You Ready thing? It's because it is a mechanics thing that is normally taught in Physics 2A. It is, and it is a topic that we need to be able to reference when we get to magnetism, because magnets interact with the world using torque, because there's a limitation to what they can do with forces. Okay, so I know that number 8 is going to be a problem for people. So I actually am going to include a solution to torque, this torque problem, in today's lecture. Okay, but for the other ones, it should be material that you have covered in Physics 2A, with 2 tiny exceptions. The other exceptions, things that weren't covered in Physics 2A at SJSU for the past 4 years. Universal gravity, not a big issue. I just wanted to note that there are different ways of viewing gravity, both in a local gravity context and a universal gravity context, because the universal gravity looks very similar to the electric equations that we're about to see this semester. So if you've had that experience, if you've seen those equations, it's going to be an advantage for you. You've done a lot of the math that is required already. Okay. There's one other, and the one other is on problem 6, driving on a half circle. Now, I know that there was circular motion generally discussed in Physics 2A, but the centripetal acceleration was never quantified. Okay. Directionality was mentioned. It's inwards. Centripetal acceleration is inwards. But the idea that the centripetal acceleration is equal to the speed squared divided by the radius of motion for circular motion. And it is inwards. I put a vector sign on it, so I better state the direction somehow. That is in the lab manual. I think it's on page like 38 or something of the lab manual from last semester. But a lot of the previous courses, except for very, very few lab instructors, actually covered it. Okay, so those are things that flat out were not covered last semester. The rest of these are things that were, if you took 2A at a community college, or if you took Physics 2A at a different 4-year. Community college, maybe you went to Evergreen, San Jose City, De Anza, etc., or some other 4-year, not Davis, then you probably have seen all of this material, because outside of San Jose State and Davis, all of this material is normally covered in Physics 2A. What topics does this entail? Really what I'm wanting you to be able to do going into this semester is be comfortable with vector operations. Vector addition, vector subtraction. Can you add and subtract forces? Numerically. While using trig. Okay, if you can do that, most of these should not be a problem, because a lot of these boil down to what's going on with the forces. But that's not all that's covered in them. Let's take a look at them. And when I go through these, I'm going to be asking the question, is this a forces question? Is this a torque question? Well, that's just the one at the end. Is it a circular motion question? Is it kinematics? Is it an energy question? Or is it a momentum question? Okay. Let's go through these one by one. Number 1. A 2.5 kilogram block is placed on an icy frictionless ramp. The diagonal of the ramp makes an angle of 30 degrees above horizontal. When you let go of the block, what is the net force and net acceleration of the block? So 2 of these should be really straight up. You know which topics they are. Net force, net acceleration. Net force means that number 1 is a forces problem, and it is a kinematics problem, because acceleration is about kinematics. Note that you don't have to use speed and time and positions for this one, you can connect force and acceleration directly, because since net force is equal to mass times acceleration, acceleration is equal to the net force divided by the mass of your object. So once you've figured out what the net force is, divide by the mass and you're set. Number 2. What is a distinction between velocity and acceleration? Velocity and acceleration are both kinematic terms. They're both statements. Velocity is a statement of motion. Acceleration is about how your motion is changing. So they're both aspects of kinematics. And speed and velocity are also terms of kinematics. Number 4. Number 4 is, why are there 2 equations for gravitational potential energy? Potential energy gravitational equals mgy, and potential energy gravitational equals a negative gmm over r. Well, I've kind of answered that already for you guys, and the question itself tells you what type of question it is. It's an energy question. Next. Number 5. Your roommate tosses your keys to you from a 3rd floor balcony 6 meters above where you can catch them. The toss is at an angle of 60 degrees above horizontal at 2 meters per second. What is the speed of the keys where you try to catch them? All right. This is a classic kinematics question. An object traveling through the air, it's only being influenced by gravity. This is a classic kinematics question. But there's a second way you could solve this. Because note that the time was never given. You were given the height that it travels through. It starts 6 meters up in the air and ends 6 meters lower. And that means that you can think about potential energy gravitational, or you can think about the work done by gravity during that change in height. Okay? Anytime you have action happening over a distance and that distance is known, then because work is equal to force times distance, that is an energy problem fundamentally. Therefore, you can solve this question via kinematics, and you can also solve it using energy. You might want to try it both ways. Draw an energy interaction diagram and see if you can find the final speed, and then go through using the kinematic equations in, I think it was page 40 of your guys' old lab manual, unless the numbering's changed in the past year. And see if you can determine the final speed from there. Okay. It should give the same result both ways. The technique should not change it. It is not a momentum problem. And it is not a momentum problem because the time isn't given. For it to be a momentum problem, you'd have to do force multiplied by change in time to get the impulse, the change in momentum. Time is not mentioned in this problem at all. Therefore, I would not use momentum to solve a problem like this. 6. 6, I've already said that this is circular motion. But that's not all that it is. It's something else in addition. You are driving on a hill that looks like a half circle of radius 15 meters when viewed from the side. What is the fastest you can drive over this hill without losing traction with the road? This phrase, losing traction with the road, there's some buzzwords in there. What is traction? traction means that you have a force interaction between the car and the ground, specifically a contact force. Okay. So what is this talking about? This is another way of rewording what this question is asking is how fast is the car going when the contact force is 0 newtons. Okay. The force of the road on the car. Now that's not the only force. You still have the force of gravity to consider because that's still acting on the car as it's going over the hill. So you have an acceleration to plug in. You still have a force. You've just lost the force of the road on the car. So it's circular motion and forces. Next, number 7. Okay. Number 7, you kick a ball so that it leaves your foot going 15 meters per second at an angle of 45 degrees above horizontal. What height does the ball reach above where you kicked it? This has all the telltale signs of problem 5, actually. It's a ball moving through the air after having some initial speed. There's a little bit more trigonometry involved, and there's a little bit more considerations of distinguishing horizontal and vertical motion. But number 7 is both kinematics and energy. Trigonometry is always something that gives people a hard time as well. Which of these involve trig in addition to the other things? The first one also involves trig. The next two, well, anytime you're dealing with velocity, you can do trigonometry on a vector. You can't do trigonometry on a scalar. There's no trigonometry for energy. No need for trigonometry on number 5. No need for trigonometry on number 6. But there is trigonometry on number 7. It's what makes number 7 more difficult than number 5. Because at the top of the motion, it's still moving horizontally. But it's not moving vertically. That's how you know about its motion at the top. It's at the top of its motion, still moving horizontally. Okay. There's my review of the topics that you need for these. I suggest pausing for a moment and taking a look at these problems. You can find them in the PDF book on Canvas, and give them a try. Try them on your own, see how far along you can get with them, and then once you've done that, come back and watch the next part of this. The next part of this is me going over the torque problem. The torque problem I've already completed. Okay, I had it prepped for you guys. Okay, so I'm going to read through it first. A standard ruler of uniform mass has a string hanging from the end of it with a 20-gram mass attached. At the same time, you rest it on 2 fingers, both at the 0-inch edge and at the 10-inch mark. The ruler has a mass of 10 grams. What force does each finger apply to the ruler? Okay. I took that information and I drew this diagram. Okay. The black line is my ruler. That's too distracting. I'll use it later in the semester. I'll come back to it. I can do the pointer for now. So we got the ruler right there. It's 12 inches long, as rulers are. It's uniform. Because it's uniform, its weight acts at the center. So the force of the earth on the stick is equal to mg downwards. And it has a value of, the mass is 10 grams. 10 grams is the same as 0.01 kilograms. Multiply that by g of, let's use 10 meters per second squared. Multiplying those out gives me 0.1 newtons. Okay, so this is a 0.1 newton force downwards. There's a hanging mass as well. The hanging mass is twice the mass. So that 20 grams is actually 0.02 kilograms multiplied by 10 meters per second squared gives me 0.2 newtons downwards. That's our two downwards forces. That's the weight of the different objects. It's being supported by two objects, your left finger and your right finger. The left finger is supporting it at the 0 inch mark, and the right finger is supporting it at the 10 inch mark, as mentioned in the problem. I labeled this point over here as a pivot point. Here's why I labeled that as the pivot point. It's because forces, when applied away from a pivot point, can torque an object into rotating. Okay, and you can test this out by just holding a pencil and pushing on it at different locations, or taking a circle or a giant sphere and pushing it in different ways. Which pushes cause it to rotate, which pushes cause it to translate. If the push is some distance away from the pivot point, so we've got a distance of 0 for the left finger on the stick, a distance of 6 inches there, 10 inches, 12 inches, then those apply torques. I need to organize this information, and I'm organizing it into this table. Okay. A lot of things have already been solved out on here, so I've got my different forces to consider. There's the forces that are on the stick. The left finger is applying a force, the right finger is applying a force, the earth is, the hanging mass for HM, and those all add up to some total. And I used a double line here to represent an equal sign. All these forces are vertical. So even though I included a consideration of some of the forces in the x direction, they're all 0 all the way down the line. Therefore, I didn't have to do that, but I just did it for completeness. Now the y direction. In the y direction, we already know 2 of these forces. And we know that the earth force is downwards, and the hanging mass force is downwards. Okay. Downwards, therefore negative. Already been calculated previously, and I therefore know these 2. I also know that the net force in the y direction is 0. I know that because it's balanced. It's resting there. It's not accelerating. Therefore, the net force on it, the total force on it, is 0. These other 2, I have as question marks. They'll eventually be these two values, but we do not know that yet. I do, because I've already solved the problem. You will soon when we're done. Next column. I want to build up to being able to talk about torques. But before I talk about torques, I need to include information about those distances from the pivot point to the where the force is acting. Okay, that is called the moment arm. Moment arm. R. Okay. And those were already drawn on the stick earlier. 0, 6, 10, and 12 inches. There's no reason to add those together. They aren't forces worth adding together. They're just distances. So I just put a big X to say, no, that doesn't even make sense to talk about. I'm using that to determine the torques for each of those, because torque is going to be that moment arm multiplied by the force that is perpendicular to that moment arm. The left finger is applying a force at the pivot point. R is 0, torque is 0. Done. The other three are going to be positive or negative. The right finger is lifting it up on the edge as if to make it go counterclockwise. Since that is making it, or trying to get it to spin counterclockwise, that will be a positive torque. The other two are trying to get it to rotate the other way, therefore the clockwise. Therefore, the earth and hanging mass forces lead to negative torques. This convention of positive being counterclockwise and negative being clockwise is just like what you did in trigonometry classes, where a positive angle is coming off of the positive x-axis and a negative angle is coming downwards off of the positive x-axis. Same convention. Counterclockwise for positive, clockwise for negative. Lastly, because it's stationary, it's not rotating, it's not angularly accelerating, therefore the net torque, the total torque, must be 0. It's a balanced situation. Numerically, I found the earth torque just to be 0.1 multiplied by 6, giving me 0.6 inch newtons. Usually for torques we would do meter newtons or newton meters, but the units are going to cancel out in the future, so I didn't see a reason to change units at this time. Similarly, the hanging mass, it's a 0.2 Newton force at 12 inches away, so that'll be 2.4 inch newtons. In order to balance these two so that the total is 0, the right finger must be applying a torque of 3 inch newtons. I can use this 3 inch newtons to find out what the force in y is by taking the torque, dividing it by the moment arm, and getting the force. So that'll be 3 divided by 10 is 0.3. And I know it's upwards, hence the positive. Oddly enough, this 0 is not because the torque is 0. It's actually for a different reason. I can't get this 0 from this 0 because of the r. You can't divide by 0. That's just mathematically not kosher. Instead, I'm looking at the balance in this green column here. It needs to add up to 0. I've got 0.1 and 0.2 newtons downwards. I've got 0.3 newtons upwards, and those three balance each other out, which means that the left finger doesn't need to apply a force at all. Okay, so you can actually do this problem by putting your finger here and letting the weight of the stick on the left and the weight of the hanging mass on the right balance each other out. And that's how that works out. There's a lot of math that I put in here and a lot of organization going on in there. I won't be needing you to do all this math. What I will be needing you to do is to understand this right here. Okay? What's going to be important when we get to the magnetism unit in March is this idea of forces being applied away from the center of mass. Okay? That these forces can cause objects to rotate. Because, as Faraday's law is going to show us, magnetic fields cause things to rotate a whole bunch. But they're not very good at making things translate. All right, that's 50 minutes in. Okay. When I did this with the other class, we spent almost 30 minutes of them in small groups going over the first 7 problems on their own. Okay. Well, in their small groups, in their breakout rooms. In our asynchronous class, we don't have that. Instead, you're going to have to rely on either the Discord channel, the Group Me page, or the discussion group. Okay. At this point, I hope that you actually did give those 7 problems a try. At this point, I'd like you to go over to the discussion page and put 2 things down. Put down something that you think you got right there, and put down something that you're concerned about there. If someone already has written about what you were about to write, respond to them instead of starting a new thread so we can keep all the ideas together so it's easier to have a conversation. Okay. Work on these as a class, and hopefully by Monday you guys will be ready for warm-up on, not Monday, Tuesday, to be one of these 7 questions. Not exactly one of these 7 questions, but something just slightly off, like change a number or change the way it's worded or something like that. And that'll be your first warm-up to do next week. Until then, practice these. If you would, and that'll see how much of the stuff from Physics 2A you're ready with. If you want to do some reading, get started reading on the Physics 2B PDF book. Okay. If you already have the book written by Knight, you can start reading chapter 20 as well. But make sure you've got this 2-way stuff under your belt first. Because there's some material that SGSU just didn't cover or didn't cover too well. Others maybe it was just covered differently at your school. Or maybe it's just been some time and you just need to refresh it. All right. That's what I want you to work on this weekend. Good luck on the discussion. We're ending 20 minutes early, but I'm sure you'll be able to put that time into really finding out. Are you ready? I hope you are, and I look forward to sharing more information with you next week. If you have questions, please let me know. Send me an email, and I'll get back to you as soon as possible. Talk to you then.